So welcome all to another session on TIFR Math problem solving. Today's problem is a little bit straightforward. So as you can see, this problem is limit supremum of 1 by n is equals to 1 by limit infimum of an. So this problem is based on this very simple observation. If you can observe this very simple fact, then this will be pretty easy to track. So first of all, we will first see what is the definition of limit supremum. So the definition of limit supremum is precisely this. That if I am talking about limit supremum n tends to infinity 1 by an, then that is limit n tends to infinity with the supremum of this set. So how does limit supremum kind of takes place? If you take, let's say for any bi's, so let's say b1, b2, b3, and it goes on so on and so forth. Let's say you have a sequence like this. So first of all, you will omit b1 and you will see that what is the supremum of this sequence, the rest of the thing. Then you will omit b2, then you will see what is the supremum of this, and that is how you are going to get a sequence of supremums. Let's say for this one some bk, for next one some bk prime, and so on and so forth, and then n tends to infinity, you will get the result as limit supremum. The same thing happens for limit infimum as well. So what is the observation that you need here? So as you can see that limit supremum is precisely this, right? So supremum of 1 by ak, if you are talking about supremum of 1 by ak, so limit supremum is just n tends to infinity with this sequence set, right? So what is that set? That is the supremum of 1 by ak such that k is greater than or equals to n, right? So now supremum of these is practically what? As a set theoretically, if you want to describe it set theoretically, it is practically 1 by infimum of this set. Because the larger 1 by ek grows, it means ek grows smaller. And that is the reason that here we are actually explicitly using that bounded positive real numbers, so that there is no negative term, there is no alternating sum. So it will grow if ek is small, right? So as a set theoretic notion, these two are precisely the same thing. Now what you just have to apply? You just have to apply limit n tends to infinity. So if you take both sides, let's say limit n tends to infinity and of, so let's call this as I1 and this as I2. So limit n tends to infinity I1 is precisely equals to limit n tends to infinity I2, because they are set theoretically, sequentially they are the same thing. Okay. So thus the limit supremum. So if you take this limit n tends to infinity of I2, this is nothing but the limit infimum of an. This is precisely the definition of limit infimum. Okay, so this is precisely the definition, and thus you have an equality. Now the only thing to check here is that what happens if the infimum of this becomes 0. So if the infimum of this becomes 0, then this will shoot towards infinity, right? 1 by infimum is 0, the limit n tends to infinity, it is 0, it is infinity. The same thing will happen here as well. For an example, you can actually take an equals to, if you take an equals to 1 by n, so this is one of such examples. So where infimum is 0, thus it is going to infinity, and here in the left hand side that will also go to infinity. So it is just a simple observation that the set of supremums of k greater than or equals to n 1 by ak depends on the choice of infimums of ak. explicitly, and hence we have the solution. So this is a true statement. This statement is. So that's it for today. We will meet with another problem in our upcoming session. Thank you for joining.